Thank you. I'm Mr. Lehner, and welcome back to Mr. Lehner's Math Extravaganza. In today's webisode, we're going to take a look at area and perimeter, and specifically with bumper cars. How cool is that? Imagine if we could take a nice class field trip to do a little bumper cars ourselves. That'd be pretty cool. But we're going to take a look at what the area and perimeter is in some student designs. If you forgot what area and perimeter is, this will be a nice little refresher. Let's take a look. In our first example, it says, find the area and perimeter from the two bumper car designs below. What conjectures can you make? Ooh, conjectures, I forgot what that is. We haven't talked about that in a while. Oh yeah, conjectures are when you take a look at what you see here and you kind of make a conclusion or an observation based off of the information. So we're going to find the area and perimeter of both designs and then see what do we learn about this, or what do we notice about our two designs. Let's start with the area. When finding the area in these designs, we're going to find the inside portion. So for this, say we're working with square feet, I'm going to count the inside. 2, 4, 6, 8, 10. I have 10 squares, so that would be, the area would be 10 square feet if I'm working with the unit of feet. Perimeter. Ooh, what's perimeter again? Oh yeah, perimeter is the outside portion. So I'm going to count the outside. Now since we're working with our handy dandy little bumper cars here, imagine the outside is like little fences that you might see at an amusement park to kind of keep the crowd under control. So each piece here is going to be, like I said, part of a fence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the perimeter in this one is 14. So my area was 10, the perimeter was 14 in this first design. Again, area was the inside, perimeter was the outside. Let's look at design number 2. In design number 2, we can tell it's a little bit different here. But we're still going to find the area and still going to find the perimeter. So let's do the inside first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My area was 10. Now to find the perimeter again, it's just like the fencing on the outside. I'm going to start at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So in my second example up here, the area was 10 and the perimeter was 18. Let's take a look at a conjecture here. I noticed that, ooh, the area was the same. They were both 10. So this covers the same amount of space as this design covers the same amount of space, even though they are both two different designs. They look totally different. They have the same area. Now what's different is the perimeter. So if I was setting up an amusement park, it's only going to take 14 pieces of fence to kind of enclose or create the perimeter for this first design. But in this second design, it's a little bit different, maybe a little bit cooler. It's going to cost me money to get 18 parts of a fence to put around the outside. So even though the areas were the same, the perimeters were different because the designs were different. Kind of interesting. Let's take a look at your turn. I know it's your favorite part in there. Mine too. It says, find the area and perimeter from the two bumper car designs below. What conjectures can you make? And again, we have our handy dandy little visual up there. So go ahead and draw out or use some math tools to help you solve with these two designs. I know your paper's out. I know your pencil's ready. Go ahead and pause the video. Okay, let's start with this guy here inside. We're going to find that area first. I'm going to count the inside. 2, 4, 6, 8, 10, 12. So the area of this figure design is 12. Let's find the perimeter. I'm going to start on the left-hand side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in this first one, our area was 12 and the perimeter was 16. Again, I counted the inside for area, I counted around the outside for perimeter, so in this design I would have 12 as my area and 16 as my perimeter. In our next one, again a little funky design here. Let's start with the area. 2, 4, 6, 7, 8, 10, 12. My area was 12. Let's take a look at the perimeter. I'm going to start at the top here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and yeah, I started here, so 24. So the area on the inside was 12 and the perimeter was 24. So again, two totally different designs. They had the same area, they covered the same amount of space on the inside, but the perimeter was different as I went through. Now some of you might have noticed that our top figure up there is a rectangle. And you might have said, well, I knew this side was 2 and I knew this side was 6, so you could have done 2 times 2 to get 4 plus 2 times 6 to get 12, and that would have equaled your perimeter there on the outside as well in there. Or you might have noticed that we get into formulas, length times width is going to be your area. You do length times width, but that'll be coming up in our covering and surrounding unit. Now when we make our conjectures, again, our areas were the same, but our perimeters were different. Now if I was a businessman, say for an amusement park, and I wanted to save money, which one do you think I would choose for the perimeter for fencing? Right, I'm going to choose this one because I only need 16 pieces of fence to put around the outside, whereas if I made this design, I'm going to have to pay for 24. But who knows, you might decide that, hey, if I have the coolest design in all the world, maybe everyone's going to come to my bumper park, and that's going to create me some revenue too. So kind of a couple different conjectures you can make there when working with this area and perimeter. Thank you for tuning in to Mr. Langer's Math Extravaganza. As always, we'll see you next time.